Hello friends, myself Dr. VANITA RAUT, working as an assistant professor in physics at ASC College Ramanatnagar. The topic of discussion is Q value of nuclear reaction. In this topic, I am going to discuss sub-points as introduction, general scheme of nuclear reaction, Q value of nuclear reaction, calculation of Q value of reaction, exothermic nuclear reaction, and endothermic nuclear reaction. In nuclear reaction, nucleus is get bombarded with energetic nuclear particle or a nucleon. Nuclear reaction is the process of change in composition of a nucleus because of bombardment of nuclear particle. In this process, sometimes energy of nucleus also changes. Ernst Rutherford first produced the nuclear reaction in 1919. The nuclear reactions are similar to chemical reactions in the sense of energy change. If incident light particle strikes the nucleus at rest, the result of nuclear reaction is the recoil nucleus and product particle. Generally, a nuclear reaction is described as A plus X, it gives Y plus B. Here, A is the incident light particle, which is also called as projectile. Capital X is the target nucleus, which can be considered generally at rest. Capital Y is the recoil nucleus, which is also called as product nucleus. Small b is the light product particle. In this case, here A and X are also called as reactants, while Y and B are also called as products. This reaction can also expressed in even a more compact form as capital X into bracket A comma B bracket complete Y. In this form, light bombarding particle and light product particle are written in the parenthesis between target and product nucleus. In nuclear and particle physics, the energetics of nuclear reactions is determined by its Q value. The overall energy released or taken up in a nuclear reaction is known as nuclear reaction energy, which is also termed as Q value of reaction. The Q value of reaction can be defined in terms of energy difference or mass difference. The Q value of reaction is defined as the difference between kinetic energies of the final products and initial reactants of the reaction. In other words, it is difference between the sum of masses of the initial reactants and the sum of masses of the final products in energy unit. Generally, it is expressed in terms of mega electron volt. Let us discuss calculation of Q value of reaction. As we have discussed earlier, the Q value of reaction can be determined by energy difference or mass difference. A typical nuclear reaction can be written as A plus X gives Y plus B. Let us consider Ma, Mx, My, Mb be the rest masses and Ea, Ex, Ey, Eb be the kinetic energies of the projectile A, target X, product nucleus Y and product particle B respectively. Since target nucleus is initially at rest, hence kinetic energy of target nucleus Ex is equal to 0. Thus, by law of conservation of energy to the equation 1, we have the total energy of reactants is equal to total energy of products. The total energy contains kinetic energy and rest mass energy. Thus, the total energy of reactants is Ea plus Ma c square plus Mx c square, while that of the products is Ey plus My c square plus EB plus MB c square. Here MAc square, MX square, MY square and MB square represents corresponding rest mass energies. The Q value of above nuclear reaction is defined in terms of energy difference as Q is equal to EY plus EB minus EA. Using equation 2, we have EY plus EB minus EA, which is equal to into bracket MX plus MA minus MY minus MB bracket complete C square. Hence, Q value can also expressed in terms of mass difference as capital Q is equal to into bracket mx plus ma minus my minus mb bracket complete c square. The Q value of reaction can either be positive or negative. Depending on this fact, there are two types of nuclear reactions as exothermic nuclear reaction and endothermic nuclear reaction. If Q value of nuclear reaction is positive, it is called as exothermic or exergic reaction. Here, in this case, Q is greater than 0, EY plus EB is greater than EA, or MX plus MA is greater than MY plus MB. The kinetic energy of the product is greater than that of the reactants. Also, the total mass of reactants is greater than that of the products. There is a net release or liberation of energy. There is net loss of mass which is equal to delta M, and delta M is equal to mx plus ma minus my minus mb, and this net loss of mass is gets converted into energy equal to delta mc square, which is the liberated or released energy. If Q value of nuclear reaction is negative, it is called as endothermic or endothermic reaction. Here Q is small than 0, EY plus EB is small than EA, MX plus MA is small than MY plus MB. The kinetic energy of the reactants is greater than the kinetic energy of product. The total mass of products is greater than that of the reactants. Thus, there is net gain in mass equal to delta M. Delta M is equal to My plus Mb minus Mx minus Ma. Thus, some portion of kinetic energy is converted into rest mass of products. There is a net absorption of energy. In endothermic nuclear reaction, energy falls short, thus minimum amount of energy is required to be supplied from outside, which is called as threshold energy of endothermic reaction. Thank you.